In previous few videos, we have seen the position of an object at rest with respect to a reference point and calculated its distance from that reference point. We have also discussed briefly about the fundamental physical quantities that are independent of each other from which we can derive any physical quantity because they are related with some natural law of the universe. We have also discussed about the units of these fundamental quantities that are reference for measurement of these quantities. In this video, I am going to introduce new physical quantities that are displacement and motion. We have seen that when we keep an object in space, it remains there forever at rest. This is the property of space. We have also seen the position of an object at different locations in space. In this video, we will consider only one dimension or single axis. In previous video, we have seen the position of an object in this axis with respect to a reference point origin and calculated its distance from origin. In this video, we are going to talk about displacement. It is defined as the change in the position of an object. For example, let's say that ball is at 3 meters from the origin initially, and now it is displaced to 7 meters from origin. Then the displacement of this ball is given as its final position minus its initial position, represented as a delta S, where delta sign specifies a finite change. So in this case, the displacement of the ball is 7 meters minus 3 meters, which is 4 meters. Thus, it is displaced 4 meters towards the positive x direction. If it would have been displaced from 3 meters to minus 1 meter, then its displacement is calculated to be minus 1 meter minus 3 meters. That is minus 4 meters, which says that the ball has displaced 4 meters towards negative x direction. Before we talk in detail about motion, we need to introduce time, which is one of the 7 fundamental physical quantity we talked earlier. In very basic level, we can define time as the progress of the events in our day-to-day life. For example, we live in this world for a certain duration of time having past experiences, living in present and see future events. As we are studying physics, we need to quantify time. That is, we need to define its exact amount of duration or to specify a unit duration for measuring the amount of progress of an event, as we have done in the case of length, whose unit is meter. Since ancient times, people used different time measuring devices like sand glass, in which the passes of time was recorded as the time span of flow of substance, generally sand, from upper bulb to the lower bulb of the sand glass. Sundial, in which the time was recorded as the movement of the sun across the sky and hence the edge of a shadow of an object called gnomon, the pointer in the sundial. Candle clock, in which the passes of time was recorded as the time span of melting of the wax between the two marks indicating the desired interval. But these time-keeping devices are not so universal so that they can be used to measure the duration of time, which could be used as a standard unit. With the advancement of technology, other advanced time-keeping devices are invented, like pendulum clock, mechanical watch, quartz clock, and digital clock that we use today. And the unit for time is defined to be second, which is used as a reference for the measuring different durations of time. But to understand the definition of a unit of the time, that is, what duration of the progression of an event could be counted as 1 second, will be a bit tricky and complex for now. For reference, you can see the definition of time in the description below. So, our clock says that 1 second is the duration of time of a tick of the second hand of an analog clock, or duration of time to display next number of the second digits in the digital clock. Let's talk about motion. For that, we are going to keep a clock with us so that we can measure the duration of an event of interest. Since we are talking about motion, we need to define it first. Motion of an object is defined as the change of its position over the passes of time. To understand this, let's go to the same space where we have studied the position of a ball. This ball is at rest now. We need to move it so that it could change its position with the passes of time. And don't forget that we have a clock to measure the passes of time. But a problem arises here, that how we can move this ball. It's not a big problem. We just need to hit it so that it starts to move. Here we are in a position to understand new phenomena of nature. That is, when we hit an object which is initially at rest in space, it starts to move with a constant speed, and it goes forever with same speed until it encounters an obstacle in its path. But what is the speed here? Speed is a measure of how fast something is moving. If we measure the distance traveled by an object in given interval of time and represent it as the amount of distance traveled divided by the time it takes to complete its journey, it is called average speed. So, when we hit the ball, it changes its position continuously with respect to a reference point. Let's record this continuous change of position with the passes of time with the help of clock. You can see that it has traveled 7 meters in 1 second. So, from the definition, we can see that the average speed of the ball is 7 minus 0 divided by 1, which is equal to 7 meters per second. From the same hit of the ball, let's record its position for other time interval. Now, it has traveled 21 meters in 3 seconds. Again, from the definition, its average speed comes out to be 21 minus 0 divided by 3, which is again equal to 7 meters per second. This shows that the speed of the ball is constant. Thus, the speed and average speed of an object moving with constant speed is same thing. You might be confused that what is the difference between speed and average speed. To understand this, let's recap the definition of average speed, which is defined as the distance traveled by an object divided by the time it takes to travel that distance. Let's consider another situation in which the speed of the ball is not constant. That is, its speed is different at different time. For example, it moves with a speed of 3 meters per second in first 2 seconds. After that, it starts to move with a speed of 6 meters per second. We are interested to calculate its average speed for a time interval of 6 seconds. You can see that the total distance traveled by the ball in first 2 seconds with the speed of 3 meters per second is 3 into 2, that is 6 meters. Since its speed is 3 meters per second, it travels 3 meters in 1 second and hence 6 meters in 2 seconds. So, it will be at 6 meters from origin at 2 seconds. Similarly, for next 4 seconds, it travels a total distance of 6 into 4, that is 24 meters. So, its final position becomes 30 meters from origin. Thus, its average speed is given as 30 minus 0 divided by 6, which is equal to 5 meters per second. But the speed of this ball is different at different time, which is 3 meters per second till 2 seconds. After that, it is 6 meters per second. So, it doesn't matter that what is the intermediate speed of the object between two positions to determine its average speed. We just need its final and initial position and time it takes to reach from initial position to final position to determine its average speed. Thus, the speed of an object is the instantaneous speed during its motion, that is, its speed at certain point of time. Thus, speed and instantaneous speed are same thing. So, for an object moving with constant speed, its instantaneous speed is same as its average speed. Okay, Let's hit the ball with slightly greater strength than the previous hit. Our formal experience says that the ball will move slightly faster than the previous one. Let's record its speed now. You can see that it has traveled 20 meters in 2 seconds. So, from the definition, average speed of the ball is 20 minus 0 divided by 2, which is equal to 10 meters per second. If an object takes more time to cover a distance, it is said to be moving slower. And if the object takes less time than the previous one to cover the same distance, it is said to moving faster than the other. You might have noticed that I have used the word distance and displacement interchangeably in the entire discussion. This is because we have studied the motion of an object in straight line. And in straight line motion, distance and displacement are the same things. We will see the difference between them in the next video. Are we missing something? We have seen that we set the ball in motion by hitting it with another object. The harder we hit the ball, the faster it goes. Here some questions arise. First, what we describe heat in terms of physical quantity that made our ball to move from rest. Second, how harder we hit the ball and how fast it will move. So the next video is going to explain the questions of the difference between distance and displacement, study heat as a physical quantity, or study the cause of motion of the ball from rest. But before that, we must be familiar with two most important mathematical tools of physics. First, the vector, and second, differential and integral calculus. The links are given in the description below. In short, in this video we have talked about the displacement of an object along a straight line, which is given as its final position minus its initial position, represented as delta S. Then we have seen a short description of time, which is the measure of progress of the events in our day-to-day life. Using these physical quantities, we have defined a new physical quantity, average speed, which is defined as the distance traveled by an object divided by the time it takes to traverse that distance. That is, average speed is equal to distance traveled divided by total time. This is all about motion along a straight line in the term of speed. Thanks for watching.